Hello everyone, and welcome back to MP Coding. Today, we're kicking off section 2 of our tutorial series, Character Device Drivers. Before we jump into any code, let's make sure we understand device files and what device drivers are. In this short and simple video, we'll cover the difference between block and character devices and what major and minor numbers actually mean. Let's get started. Have you ever peeked inside the /dev folder in Linux and wondered about all those unusual files? Things like TTY1, MMC block 0, GPIO chip 0. This directory holds special files called device nodes. They're not regular files for storing data. Instead, they act as interfaces to hardware or kernel features. For example, if you shut down your Raspberry Pi, remove the SD card, and plug to another computer, you will not see most of these device nodes. The /dev directory is typically mounted as a temporary file system, which resides in RAM. The kernel and udev create these nodes dynamically at boot time. They do not persist on the SD card. Let's check the details for MMC block 0 and TTY0. Run ls-l/dev/mmcblk0 /dev/TTY0. Notice the first character, B for block device, C for character device. Block devices are for storage, like SD cards, SSDs, or USB drives. Data moves in fixed-size blocks, usually 4 kilobytes. The kernel can cache these blocks and even reorder operations for efficiency. Character devices handle everything else: serial ports, keyboards, GPIO pins, sound cards. They deal with raw streams of bytes, no block buffering involved. Think of block devices like reading a book. You get full pages at a time. Character devices are more like a direct audio feed. You receive exactly the bytes as they come, one by one. If we look these two numbers, the first is the major number. It tells the kernel which driver to use. The second is the minor number. It tells that driver which specific device instance to handle. For major 179, that's the MMC block driver for SD cards. Minor 0 is the whole card. If we look the MMC BLK0P1, minor 1 would be the first partition. Here major 4, that's the TTY driver for serial consoles. Minor 0 is the first one. To see how minors work in practice, run this command to look at the TTY0, 1, 2, and 3 devices. You'll notice the minor numbers incrementing for each. To get a full list of registered major numbers and their drivers, run cat/proc/devices. Here we can see the list of character devices. Here list of block devices. Important point: the file name of a device node doesn't matter at all. What counts is just the major and minor numbers. Let's prove that with examples. We'll start with a character device, the serial port. On a Raspberry Pi, TTY-S0 is the first UART. If you don't see it, you need to enable the serial port. Run sudo raspi-config. Go to Interfacing Options. Select Serial Port. I don't use the login shell over serial, so I will not enable that. Then enable the serial port. You need to reboot the system. Once rebooted, check the device numbers of TTY-S0. You'll see something like this: major number 4 and minor number 64. To test the serial port, let's create a loopback by shorting the TX and RX pins on UART 0. Here in my board, I have short these two pins using jumper wire. First, install screen if it's not there, sudo apt install screen. Now open the port, sudo screen /dev/TTYS0, baud rate, I will give 9600. Hit enter. If we type something, it should echo back, confirming the loopback. To exit from screening, press Ctrl+A, then D. Next, create a new node with the same major and minor of this TTY-S0 serial port device node. Sudo mknod my_node, C for character device, major number 4, then minor number 64. Here you can see new file have been created. Now let's open this new node, sudo screen my_node, 9600. It works exactly like TTY-S0. Same echoing. That's because the kernel sees the same major and minor. it routes to the identical driver instance. Let's do the same for a block device. We'll read the first 512 bytes from the SD card in hex. Type sudo hexdump. Hexdump shows binary data as hex values. --c/dev/mmcblk0-in 512 pipe head. You should see hex values of the first 512 bytes of the SD card. Now let's create a new node. Sudo mknod my_nblk space b for block device, then major 179 and minor 0. SAM as mmcblk0 device node. Now let's run the hex dump for this new node. Change this to new node. You can see the exact same output. Again, the file name is irrelevant. Major and minor numbers define the device. That wraps up our foundation on device files. Next time, we'll start writing our first character driver. See you then.